Hello and welcome to our very first lesson of Honors Advanced Algebra. We are using the Springboard textbook, which you don't have yet. So, of course, you should be looking at the Word document or the PDF version so that you can follow along with this video and take some notes. So our textbook is divided into units, and the units are divided into activities. So we're in Unit 1, and our activity 1, which is arithmetic, sequences, and series. And our lesson 1-1 is called arithmetic sequences. So today we're going to learn about arithmetic sequences. We're going to see our learning targets here. It'll tell us exactly what we're going to learn. So first, we want to be able to determine whether a given sequence is arithmetic. Second, we want to be able to find the common difference of an arithmetic sequence. And finally, we want to write an expression for an arithmetic sequence and calculate the nth term, or what we call any term of a sequence. So first, we're going to look at an arithmetic sequence in a real-world situation. And I'm not going to read the whole paragraph to you, but this is a relationship between carbon atoms and hydrogen atoms in different alkenes. And so if you see the table of values, you can see your carbon atoms go from 1 to 6, and then your hydrogen atoms, well, they go 4, 6, 8, 10, 12, and 14. So we can kind of see the relationship happening. And our first question, what they're going to ask us to do is to graph the data in the table. Okay, so if we do that real quick over here on the side, we'll kind of get a visual of the data. So I'm going to start by making a grid. I'm going to make this my x-axis, which is going to be my carbon atoms, and I'm going to make this my y-axis, which is going to be my hydrogen atoms. And so my carbon atoms just go from 1 to 6. Okay, so this is kind of like our n. This is our f of n, or our x and y. So if I just go by ones, 1, 2, 3, 4, 5, 6, and then I have to go up to 14, and so I'm going to just kind of go by 2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So I'm still going by ones, but I didn't want to squish all the odd numbers in there. All right, so these are going to be our hydrogen atoms, F of n, and these are our carbon atoms, N. And we're going to look at the relationship between the two, and we're going to write a function, F, where F of n is the number of hydrogen atoms. Oh, and then we're going to also describe the domain of the function. So there's our first question. All right, so let me plot these points real quick. So 1, 4, and 2, 6, and 3, 8, and 4, 10. 5, 12, finally 6, 14, and I see a straight line. And so that is very indicative of an arithmetic sequence. So it's going to look a little bit like an equation that you're familiar with, y equals mx plus b. So to write this equation, we're going to need the slope and the y-intercept. So the slope's pretty easy to find. You know, rise 2, run 1, rise 2, run 1, so our slope is 2. So f of n is equal to 2n. And then we need our y-intercept, which I don't see, but I can imagine where it's going to hit the axis. It's going to be right there at 2. If we follow the same pattern, we know it's going to hit right there at 2. So 2n plus 2 is our equation. The domain is going to be, it looks like our domain are just these positive integers, 1, 2, 3, 4, 5, 6, and so on. So for our domain, we're going to say our domain is n is a positive integer. Okay. All right, now, from that example, we're going to learn a little bit about arithmetic sequences. Any function where the domain is a set of positive integers, like we see here, is called a sequence. The values of the range of the function are the terms of the sequence. When naming a term of a sequence, subscripts are used rather than traditional function notation. So instead of f of 1, we're going to actually call that a sub 1. That's going to be term 1. Okay, f of 2 would be a sub 2, and so on. So with that in mind, here's our sequence. These are the terms right here. We want to find a sub 1 and a sub 3. Okay, so, oops, sorry. A sub 1 would be our first term, and a sub 1 is 4. And a sub 3 That's our third term. And that is going to be 8. So those are just the number of terms in the sequence. Next, we want to talk about the difference. So the difference is actually the difference between the terms, and that common difference is what caused this line to be straight. And so if we look at our common difference, if you look at the terms, we've got 4, 6, 8, 10, 12, 14. The difference between them you can see is 2. And you can get that difference by subtracting any two terms together. So if you take any two consecutive terms, I should say. So if I took 6 minus 4, okay, it's going to be the same as if I took, 8 minus 6, and so on. Maybe I took 10 minus 8. In all cases, we're going to see that common difference is 2. And we use a little d to show common difference. Okay? So sequences like the one above, we call those arithmetic sequences. And an arithmetic sequence is a sequence in which the difference of the consecutive terms is a constant, like 2. And like I said before, a common difference is represented by little d. Okay, so common difference, little d. And that's going to be part of the formula that's going to help us find the nth term like we saw in our opening learning targets. Okay, page 2. Here we go. We are going to now start looking at something called what we call the nth term of a sequence. So thinking about that common difference. So that common difference is really important. Okay, that common difference d. It's part of the formula, like I said. So it says use a sub n and a sub n plus 1 to write a general expression for the common difference. So we are going to get the common difference by subtracting the previous term from a term. Okay, so if you think about it, the previous term would be a sub n. The term itself would be a sub n plus 1 if you think about the order of things. So a sub n plus 1, a term, take away its previous term, a sub n. And that's how we're always going to find a common difference. It's really just subtracting the terms. All right, so let's go on to number 5, which says determine whether the number of carbon atoms in the first 6 alkanes forms an arithmetic sequence. Explain why or why not. All right, well, we've got 1, 2, 3, 4, 5, 6. Okay, so first thing I would ask myself is there a common difference? So if I look at the numbers, not too hard to figure out. 2 minus 1 is 1. 3 minus 2 is 1. 5 minus 4 is 1. So I would say yes. Okay, there is a common difference. Of 1. So you have to be able to state what that common difference is. All right, we get into a check your understanding, and we don't always get time to do these, but I want to do this today. Like I said, I'm taking this first lesson a little slower, just so you can get used to the format. And so we've got a little check your understanding where we're going to decide whether or not each sequence is arithmetic. And if it is, we want to get that common difference. All right, let's change colors and mix it up a little bit. We'll do a little purple. So I've got 3, 8, 13, 18, 23. So I want to look for that common difference. And it looks like 8 minus 3 is 5. And 13 minus 8 is 5. And yep, it's looking like 5. So I would say arithmetic. And common difference is 5. 7 looks like a fun sequence. 1, 2, 4, 8, 16. It looks really nice and pretty. Is it, however, arithmetic? Do I have a common difference? 2 minus 1 is 1. 4 minus 2 is 2. Nope, I do not. So that is not arithmetic. Okay, we'll go on to number 8. It says find the missing terms in the arithmetic sequence. All right, well, we need to get that common difference first. So let's do that. So let's see. I want to take 28 minus 19. And 28 minus 19 is going to be 9. So our common difference is 9, which means we just have to add 9 to each term to keep this thing going. So if I do 28 plus 9, I'm going to get 37. And 37 plus 9 is 46. 46 plus 9 is 55. And finally, 55 plus 9 is 64. So we finished the sentence. We finished the sequence. Okay, take a breather. And then what we're going to do is we're going to actually go in and start writing the formula for finding any term. Okay, so we've done some of the pre-work to help us. We've talked about common difference, and we've talked about naming the terms, and we know if a sequence is arithmetic or not. So we're going to do a little development of this formula. Once we get the formula, we'll practice applying it, and that's really what you're going to be expected to do. Not so much of this development on your own. So that's what we do together, and that's what I'm going to explain in this video. But when it comes down to it, you're going to have to be able to apply the formula. So we're going to get there. All right, number 9. It says write a formula for a sub n plus 1 in number 4. Well, in number 4, we already have a sub n plus 1 in the problem. We wrote in item 4, we had written d equals a sub n plus 1 minus a sub n. If I want to solve it for a sub n plus 1, I know I can just add a sub n to both sides, really. So a sub n plus 1 is actually equal to, if I add that a sub n to the other side, I get d plus a sub n. So just rearranging the formula that we wrote in number 4. So what information is needed to find a sub n plus 1 using this formula? Well, to find a sub n plus 1 using this formula, I need the common difference, and I need a sub n, which is the previous term. So I need two things. I need the common difference and the previous term. All right, now there are two ways to write a formula that we're going to be looking at. And the two ways to write the formula are called the recursive formula and the explicit formula. So finding the value of a sub n plus 1 in the formula we wrote in item 9 requires knowing the value of the previous term. That formula is called recursive formula. And that's great if you have that term. Okay, common difference, and you know the term that came before it, easy. You just add that difference back. But when we don't have that information, we're going to have something called an explicit, which is just a little bit different. So in an explicit formula, the terms in the arithmetic sequence can also be written as the sum of the first term and a multiple of the common difference, and that's called explicit. And it's going to allow us to calculate any term. And we're going to look at that with the same example of these hydrogen atoms. All right, let's change color again. We'll go to green, how about? So complete the blanks for the sequence here. So what we're going to do is look at, so a sub 1, which we know, that's our first term 4. Common difference, we already figured out as well. We know that's 2. Okay, now to get the second term, we need that first term, and we're going to add to it just a 1 times 2. Because 1 times 2 is 2, plus 4 is 6. Remember, order of operations, you've got to do those multiply first. So if I want a sub 3, I'm going to do 4 plus 2 times 2. And so on. So if I just continue the pattern, and I got to be careful because I think when I get to the bottom, they jumped to a sub 10, didn't they? Okay, so we'll come back to that in a second. So this would be 4 plus 3 times 2. Well, that's 6 plus 4, 10. And 8 plus 4, 12. And 10 plus 4, 14. All right, so now let's see what happened. When it was the 6th term, we did 5 times 2. When it was the 5th term, we did 4 times 2. So if it's the 10th term, we're going to do 9 times 2, which is 18, and 18 plus 4 is 22. Okay? All right, so we should start to see a pattern here. On the next page, we're going to continue developing this formula. All right. Number 12, write a general expression, a sub n, in terms of n, for finding the number of hydrogen atoms in an alkane molecule with n carbon atoms. All right, so we're going to kind of squeeze this in here a little bit. So a sub n equals, and we know we're going to start with 4. Okay, that's our first term. And then we use the number of terms minus 1, if you remember. Number of term minus 1. So n minus 1 and then times 2. That gave us our common difference. Basically, that's developing our formula. So if we want to do that 10th term like we had in that last row, okay, we want to find 10 carbon atoms. If I'm looking for a sub 10, remember I did the first term 4, but then I did 9. That was 10 minus 1 times 2. which is 18 plus 4. That gave us that 22 that we found. Okay. Now, if it had 38 hydrogen atoms, now this is a little different. Find the number of carbon atoms, and we have 38 hydrogen atoms. Now remember, hydrogen atoms, that's going to be our F of n. So this time I'm going to put my 38 on this side of the equation. 4 plus, and then what I don't know my n this time. I don't know my carbon atoms. So n minus 1, but my common difference, of course, is 2. So I just need to solve this little linear equation. I'm going to subtract 4 on both sides. So minus 4 is going to make that. I'm going to move over here so I have room. If I subtract the 4 on both sides, I've got 34 equals n minus 1 times 2. Or I could just distribute 2n minus 2. And then if I add 2, I've got 36 equals 2n. And if I divide by 2, n equals 18. Okay, so that means that I would have 18 carbon atoms if I had 38 hydrogen atoms. So that's just working backwards. Sometimes we're going to have to work backwards. All right, the moment we've been waiting for, the formula. We pretty much have it. Now in number 15, they're going to ask us, I'm going to highlight this big because that's where we're going to see our formula. And it says, use A1, A sub 1, D, and N to write the explicit formula for A sub n, the nth term of any arithmetic sequence. Wow, that's a lot. Okay, so basically, to find any term, first term, last term, 30th term, 10th term, we are going to need to use a formula. And here's what it's going to look like. We are going to use A sub n, okay, that's like any term, equals A sub 1. We need the first term, that was at 4, plus the term minus 1, so n minus 1. And then finally times the common difference. So that is our formula. We developed it today. All that work we did prior to this was to come to this point and get this one formula. And then what we'll do after that is we'll practice using it. Okay, so again, take a breath, write that formula down. Make sure you have it handy because we're going to get a few formulas. And you got to have them all handy so you can pull them out whenever you need them. So note card, sticky note, front page of your notebook, find a place to keep track of your formulas. All right, now we're going to practice this formula and then we'll be almost done, I promise. Let's go to blue. So number 16 is a good practice problem for us because this is really what we're getting to. It says find the 40th term. Okay, find the 40th term. Okay, and they gave us the first term and the common difference. That's perfect. If I need to find a common term, they've given me everything I need if I need to find the 40th term. So I'm going to just write my notes over here. Okay, so to get used to my formula, I usually write it down most of the time before I do my work. It's easy to plug in. So I want the 40th term. So basically I want A sub 40. And A sub 1, which is the first term, that's 6. And then n minus 1 is 40 minus 1. And then my common difference, they told me, is 3. So they gave you everything. I call this the plug and chug problem. They gave you everything you need. So A sub 40 equals 6 plus, and then 40 minus 1 is 39 times 3. And then you might want to go to your calculator. 39 times 3 is 117. So A sub 40 equals 6 plus 117, 123. So the 40th term of that sequence is 123. So sure, you could have written out all the numbers, but 40 numbers is a lot to write out. Yes, you could add 3 every time and you could get it, but this is a little quicker way to do it. All right, we're going to do one more practice problem on this page, and then I might have time to do a try these at the bottom. We will see. But let's look at part B. Switch colors just so we can keep it separate. Do a little pink this time. Find the 30th term. They didn't identify everything for you. You had to find a couple things on this one. So for part B, we are going to first write our formula. So A sub n equals A sub 1 plus n minus 1d. 30th term, A sub 30. A sub 1, I just gotta look at the sequence. It's a 37. Okay, now n minus 1, my n is 30, so 30 minus 1. and my difference. Okay, now this sequence is actually decreasing, isn't it? So when I do my common difference, let me come up here and do that real quick. My common difference is 33 minus 37. It's going to be negative, actually. So my common difference is actually negative 4. Okay, so negative 4. All right, now we calculate. So I have 37 plus 29 times negative 4. Okay, and you could do all that at once on your calculator if you want, and you would come up with a sub 30 equals negative 79, which makes sense because it's decreasing by 4. And you're going to get to the 30th term, you're going to be in the negatives for sure. All right, so that's the big idea of the lesson, is being able to use that formula. But in Springboard and College Board, we like to work our way up to those big ideas by giving you real world examples and then developing formulas. We don't always have time to do that, but it's day one. And really, we had plenty of time for you to watch this video and kind of help do that. So I think that's all I'm gonna do right now, and give you some time to try these, which you'll see here, okay? And then on the next page, you have some practice problems. And so, you've got to check your understanding. You also have a lesson practice, okay? And the entire lesson is uploaded, fully done. It's different colors because I did it all, by hand last year and uploaded everything. So I uploaded the answer page for that. And then when I meet you virtually, then I'll ask, like, which one of these do you guys want to go over? And then I can go over them with you and show steps and everything. So you just want to make sure that you've watched the video, and you can even take a couple days to watch this one because it's a little longer. So good luck, and let me know if you have any questions, and I will see you.